Good morning, and hopefully you've just watched the review of the exponential function video and have made your corrections and have taken a picture of those corrections and submitted them to me. I'd like to introduce you to logarithms. Now, logarithms are a part of exponents. They are the inverse of the exponential functions. What does that mean? What does an inverse mean? It means that they undo each other. Like subtraction is the inverse of addition, division is the inverse of multiplication. Okay, so they are inverses, they're going to undo each other. Okay, and typically what we're doing with logarithms is we use this feature, this inverse function of exponents, to solve for that variable in the exponent. Okay, now this is obviously different, right? If I had 2 times x is equal to 32, I would just divide by 2 and divide by 2, right? I'm undoing or taking the inverse of multiplication, division, and I get x is equal to 16. We get that, okay? But this is a different problem. This is 2 to some power is equal to 32. Now maybe you already know the answer is 5. But the question is how do we figure that out if we don't know the answer? If it's a different exponent, or that it doesn't necessarily go into it evenly. 2 to the x of 17. I mean, 2 does not go into 17. So what is that exponent, and what does that look like? So that's what we're using logarithms for, okay? And it actually is pretty simple. This is a very important thing, and I will keep going over it, right? Logs ask the question, what exponent of the base gives us the answer? Now remember, this is base, okay? This is the exponent, and this is the answer, okay? So, remembering that and keeping that all in mind as we move ahead, to solve this, we are going to rewrite the equation so it looks like this. Log, which means logarithm, base 2, here's my base, here's the answer, and here is the exponent. Because remember, the log asks the question, what exponent of the base gives me this? So when this is read, log base 2 of 32 equals or is something. So I could plug that into a calculator and I would find out that x is equal to 5. 2 times 2 times 2 times 2 times 2 gets me to 32. Okay? So that happens really simple, right? So 4 to the x is equal to 16. So if I want to write that in log form, that's going to be log of base 4, it's a subscript, of the answer is equal to x. Okay, maybe I have, don't let it fool you. I mean, it's really not difficult. So 9 to the x is equal to 343. I don't know. But if I needed to solve it, I'm going to think of it this way. Log 9 of 343 is equal to x. Okay? Because the question that the log answers is what exponent of the base gives us the answer? What exponent of 4 gives me 16? What exponent of 9 gives me 343? Okay? And that's what we're going to be looking to do here. So, a few quick notes and review of some of the things that you know of exponents. Any positive number raised to any power cannot equal a number less than or equal to 0. You're like, what in the world does he mean by that? Well, think about it. 2 to the 4th. 2 times 2 times 2 times 2. Oh, that's 16. Okay. 2 to the 0. Well, if I remember my exponent rules from Algebra 1, anything to the 0 power is 1. 2 to the negative 4th, well, what's that like? Well, again, going back to Algebra 1 and remembering my rules of exponents, if I have a negative exponent, it's going to flip over and lose its sign. So that means this is actually 1 over 2 to the 4th, which is equal to 1 over 16. So you can see that even though I've gotten even to the negative numbers here, right? I've gone down, I've gone from 4 to 0 to negative 4. This number here is still going to be greater than 0. And that will always be the case. Now that's really helpful because that means this is true, that the logarithm of a negative number, or 0, is undefined. It doesn't exist. So if I have a problem that looks like this, log base 2 of 0, in other words, remember the question, what exponent of 2 gives me 0? The answer is undefined. What exponent of 2 is going to give me negative 3? Again, the answer is undefined because there is no way I can get smaller than 0. I can't even get to 0. This number is going to get increasingly small. 2 to the negative 776th power is going to be a super small number, and for all intents and purposes is 0, but it's not 0 actually. So we just need to keep that in mind as we go through and work out some of these problems, okay? So, alright, so kind of looking at this, right, we should be able to rewrite exponent functions as logs and vice versa, okay? And sometimes it's all you have to do to solve them. 2 to the third is equal to 8, so that's what it would look like. Log base 2 of 8 equals 3. 3 to the first power is equal to 3. Well, that's just log base 3 of 3 equals 1. Okay? This one didn't print, and I left that out, so that's good. So log 5 of 1 over 25 is equal to negative 2. So remember that this is the exponent, this is the base, and this is the answer. So that means that 5 base to the negative 2 exponent is equal to the answer, 1 over 25. Okay? So here we are again. Log base 14 of 16 is equal to 2. How do I rewrite that? Well, that just becomes 4 squared equals 16. Log 6 of 1 is equal to 0. Well, that just becomes 6 to the 0 equals 1. And then 10 to the negative 2 is equal to 0.01. Okay, so if I'm writing that in log form, that's going to be log base 10 of the answer, 0.01, is equal to the exponent. Okay? Hopefully that's not too difficult and that makes some sense too. Alright? So, as we go through this, alright, we want to look at a couple different things. Let's cover some of this up, alright? So, evaluate the following logs. Now, we can always use a calculator, alright? And some of this is going to be, you will use a calculator, yes. Okay, some of you are going to quickly resort to math type and hope that it explains it all to you, and, and that's the way that's going to sit. And that's the reality of this. But, 5 to the 1, what exponent of 5, right, is equal to 125? Well, let's see. 5 squared is 25, and times 5 is 125, right? 5 quarters is $1.25. So that means the answer here is 3. Okay, so again, log 8 of 1. Well, I could jump on the calculator, but if I think about this, remember, what exponent of 8, this is the question that the log always asks, what exponent of the base equals the answer? What exponent of 8 equals 1? Well, if I remember my rules of exponents from Algebra 1, anything to the 0 power is 1. So that means x equals 0. What exponent of 12 gives me 12? 12 and that is going to be x equals 1. Okay? Not too bad. Same thing. Log of 1/4. What exponent of 1/4 gives me 1/4? Well, that's just 1. Okay? What exponent, this is a fun one, okay? What exponent of 4 gives me 4 to the negative 0.38? Well, if I write that in exponential form, there's my base, here's my exponent of 4 to the negative 0.38. Well, everything's the same, so that means this is equal to that. So x equals 0.38. Okay? Hopefully that makes some sense. Now, this one's a little more fun. Okay? So what we have here is we have 4 to some exponent is going to be a half. Okay? So there's a couple clues here that we need to look at and pay attention to. Alright? First one. If this number, the denominator, okay, is less than the base, then your answer is a fraction. Okay, well that means my answer is going to be some fraction, because 2 is less than 4. Okay, oops, I didn't cover that. Something was written there. If a fraction, then your exponent is negative. So if this whole thing is a fraction, then my answer is negative. So now the relationship is I'm looking at and trying to determine and figure out here is this. How do I go from 4 down to 2? Well, I take the square root. The square root of 4 is 2. So the square root, if you remember, a to the m over n is going to be equal to n a to the m. So in other words, if I take what I'm doing here, right, at the square root of 4, then that means it's going to be 4 to the 1/2. So 4 to the 1/2 is going to get me 2. And then to put the 2 in the denominator, that's where that negative sign comes in. So this is going to be negative 1/2. Okay? That's a little tough, I admit, but we'll work on that. Okay? So, the other thing here that we need to pay attention to is this idea of common logs. Okay? And if you think about like scientific notation, you know, where everything is written into powers of 10, well, common logs are everything with the base of 10. Okay? And we don't typically write the base of 10. It's just understood that there is a 10 there. Just like it's understood that this is the square root and that there is a 2 there. We don't write that 2. We just understand, oh, it's the square root. Same thing here. We don't have to write the 10. So this is log base 10 of 100. What exponent of 10 gets me to 100? Well, that is 2. Okay, so what exponent of 10 is 10? Well, that's 1. What exponent of 10 is 1,000th? Well, that is going to be, I'm going in the negative direction, right? So that's going to be negative 3. What exponent of 10 gets me 1,000? That's going to be positive 3. Okay? And these you can do on your calculator. This is the thing that is the most important to realize, is that your calculator is set up to do base 10. So anytime you hit the log button, it is assuming that it is a base 10. That's great, except if you have something like this. Log 4 of 32. So if my calculator says I can't do this because it's assuming a base 10, then what in the world do I do? So there is one way to do this, and it is the change of base formula. Okay? Change of base formula. Alright? And it's fairly simple. It's going to be, so this A here is the base you want to change it to. Okay? So in other words, for us on the calculator, this is going to be 10. So that I can do this on the calculator. Right? So this is going to be log of the big number, the answer, divided by the log of the base. Okay? So if I'm doing log 4 of 32, then that's just going to be log 32 divided by log 4. Understanding that my base is 10. This I can do on a calculator. So let's take a look at that and check this out. Alright? So here's my calculator. And again, it is assuming, okay, and I don't know, it's really hard to see. I don't know if I can zoom in too much more with that, but you can, if you notice above and you remember the calculators we had in school and whatever, you can see that there's a 10 to the x. So that's the second of that button. So it's already telling us that this is a log base 10. Okay, so in order to do this, I'm going to put parentheses, and I'm going to do log, okay, of 32, close the parentheses, all right, divided by log of 4, and close the parentheses, enter, and that's 2.5, and that would be my answer here, okay? Now you can see the difference, right? If I just do log of 32, that's, remember, it is saying what exponent of 10 gives me 32, and that's not even close. That's the wrong answer. So I need to figure out what is happening here, okay? And pay attention to that. Now, if you have one of these more advanced calculators and stuff like that, you can most likely go here and scroll down. Whoops, right here. And you can choose that one. And it allows you to do this. So I can plug in 4 here. And I can move over and plug in 32. And now you can see that it's set up. Log base 4 of 32. And that's going to give me 2.5. Okay? So, this is the work for this week. And this is what you are going to be working on. Okay? Some of them are going to be very simple logs, okay, where you should be able to figure out what the answers are without using a calculator. And then some of them are going to be a little more difficult, and you're going to have to either use the change the base or find a better calculator or something like that online, okay? The log buttons on your iPhone calculator or your Android calculator are also going to be log base 10. So don't get caught up in like, oh, I'm just doing log something. Okay, no. It's log base 10. So you're going to have to use the change the base formula. Okay, so let's look at a couple problems here. All right. So again, I'm just going to write out the change the base formula. I'm not going to do the answers for you. That's something that you can do on your calculator. I gave you an example of that in the video of how to do that, alright? So remember that it's log of the big divided by log of the small. So the log of the big, and remember I'm changing my base to 10. I can change my base to anything, and that is going to become important next week, next academic week, when we look at how to actually solve exponential functions and stuff like that. So we'll work on that, okay? And then that would give me my answer, okay? Now, this is not the same as log of 62 divided by 5. That's different. Because the orders of operation are going to say divide this, 62 divided by 5 first, which gets me 12.4, and then take the log of that. And that's not the same as log 62 divided by log 5. Okay? Log of the big, log 12 divided by log 2. Log of the big divided by log of the small. Okay? And that's how we work out the change of base formula. Okay? I'll do one more of these on the calculator so that you can see. I'll clear this so we have a good clear screen here. Alright, and I'm going to do log 2 of 12. Okay, so it's log of the big, 12, okay, divided by, now I'm going to check something here, alright, I'm going to try it this way, and then we'll see if we can compare the answers here. So, alright, so let's make sure that it did my orders of operations right. It's telling me that it's 3.6 basically. So I'm going to do it the way I did it before. I'm going to put the log of 12 in parentheses completely to say, hey, make sure you do that first. And then I'm going to do log of 2 and close the parentheses. Okay, and we get the same answer. So it is working out the orders of operations correctly. You just want to make sure that that is going to be true and that that happens, okay? So that is the work for this week. Now remember your assignment, okay? That is the lesson for this week, excuse me. Your assignment for right now, today, is to have taken notes on this video. So if you've missed anything, go back, review it, write some notes down, take a picture of those notes, and then send them to me. Okay? Tomorrow, Wednesday, the 27th, an Edpuzzle will post of this same exact video with some embedded questions. I want you to go through, answer those questions and stuff, and then the Edpuzzle will let me know that you did it. And then on Thursday, you're going to get a worksheet that covers some of these problems, both some of the simple logarithms where you're able to figure it out without a calculator, and then some which you're going to have to use to change the base formula. Okay, again, if you have any questions, reach out, let me know through the Remind app. Is the easiest one because I see that all the time. Emails, it takes me a while sometimes to find them. Sometimes it gets buried 20, 30 down, and I might not get back to you as quickly. Remember that I have office hours on Tuesday and Thursday, an hour in the morning, and then also an hour in the afternoon. And then we have our optional Wednesday virtual check-in, again, which will be tomorrow at 1:30. Okay? Hope you're all doing well and we're all doing safe. And doing what we need to remain safe. All right? Thanks and have a great day.